So GATE 2011, we'll start with doing the numericals. So first we have question number 44, which is a CPM based question. So basically if you know how to make a diagram, that's great. If you don't know, that's also okay, we'll just draw it. So you have these all activities A, B, C, D, E and F, and you have the duration of A in days basically. So 3, 2, 5, 6, 5 and 3, and it says that let's just start by drawing the diagram. Over here we can start like a small diagram. Okay, so A is the first activity, B and C follow A, so we can do B, we can do C, follow A. Activity D follows B and C. Activity D over here, B and C, and activity E follows C. So E follows C. So over here, E follows C. E follows C will be over here, and F follows D and E. So this will become F. This will become F, which follows D and E. Okay, so now let's just write the duration. So for A to B, or you can just write over here 3, then B 2, then C 5, D 6, E 5 and F 3. So we have to find the critical time to complete the project. Now critical time, which means the time in the critical path. Okay, so critical path means the path which takes the most amount of time. So A is the first activity and F is the last activity. So we have to find the way, like how the activity will go. So first we can have A, B, D, F like in a straight line. So that will be 1, 2, 3, 4, 5, 5 plus 6, 11, 11 plus 3, 14. So you have 14 days over here. Then you can have A, C, E, F, A, C, E, F, which will be 3 plus 5, 8, 8 plus 5, 13, 13 plus 3, 16. So you have A, C, E, F, 16 days. Now you can also have A, C, D, F. What will this have? 3, 5, 8, 8 plus 6, 14, 14 plus 3, 17, 17 days. So this path takes the most amount of time. So this is the critical path, and the critical time is 17 days. So you have to, this is a very like CPM word, seems hard, but it's actually quite easy once you understand the logics behind it. Now we move on to question number 45. Question number 45 says maintenance cost of a building will be 2 lakhs after 10 years. The annual sinking fund required for such maintenance at 6% interest per annum will be what? So basically first we have maintenance cost of building will be 2 lakhs after 10 years. So time, we have 10 years, time or n, small n. Then maintenance cost of a building over here means sinking fund. Sinking fund is your maintenance cost only, so it will be rupees 2 lakhs. So now you have 2 lakhs. Your rate of interest is given, which is I, which is given as 6%, and you have to find the annual sinking fund. Annual sinking fund, or basically annual sinking installments. So if you remember the formula, A or I, basically whatever you want to write, let's go with I. I is equal to SI 1 plus I to the power of n minus 1. So this is your sinking fund formula, where I is your annual investment. You have to find I only. We have to find I only. So we put all the values. 2 lakh into, again I is 6%, which is 6 by 100, which will be 0.06. So 2 lakhs into 0.06 by 1 plus 0.06. The time required is 10 years minus 1. When you calculate it, it will come around rupees 15,200, which is your annual maintenance fee. So yes, when you solve numericals in GATE question paper, you only get like the numericals, you only get the question, and then you have to enter the answer. So like if your answer was 15,200, you will have, there will be a box there and you will have to enter it 15,200. There won't be options. Okay, moving on to question number 50. 50 and 51 are linked questions, so we'll just write all the details given in the question. A building has a plot of 500 square meter. Plot area is 500 square meter. Allowable height is G plus 7. G plus 7, you have meter here, so it will be like 8 floors, so 8 into 3 will be 24 meters. Then you have ground coverage 40%. FAR allowed is 2. It can also be written as 200, okay, so don't be confused. 2. Next, this question has more part, but I'll first solve question number 15, then we'll move on to the next part of the question. Also, one more point, area to be utilized for paved access roads is your 10%. So when you're at 10%, it means 10% of the plot area. Now we have all the given options. So the question is like, if maximum allowable FAR is used, then what will be the minimum ground coverage? So you have plot area given, you have maximum allowable FAR given. So we all know that built up area is equal to plot area into FAR. And also like mark this as an important formula. So your built up area will be 500 into 2, which is 1000 square meters. Now you have this, now 10% of that area will be under paved roads, 10% area will be paved roads. So as I said, 10% of plot area. Don't get confused, built up area and plot area are different things. 10% of plot area. So it will be 10 by 100 into 500, 50 square meters. So basically available ground area you have is, plot area you have 500 square meter, and which 50 square meter is going in the road, so available is 450 square meters. Now we also have been given maximum ground coverage area, which is 40%. So if we are using that, if maximum ground coverage used, it will be 40% of 500 square meter, which will come off 200 square meter. Now as we have seen that the available allowable height was g plus 7, which is 8 floors and 8 floors. So basically, if this is ground area used, this is, we have the whole built up area. So if built up area is 1000 square meters, so in every floor, if equal area is used, area on each floor will be 1000 square meter by 8, which is 125 square meter. So now we have area on each floor, meaning area on ground floor also is included over here. So now if we have to find out, we have the ground floor area, we have the FAR and everything. So what is the minimum ground coverage for full FAR utilization? For full FAR utilization, this will be your area on each floor divided by the plot area. So basically what happened is that you were given all these different informations. You were given the plot area, you were given the ground coverage, the FAR. We first took out the built up area, which is the plot area, into FAR, which is will be 1000 square meter. 10% we of the area is paved road, so we took that out. Available ground area 450, maximum ground coverage use 40% of this much, 40% of the plot area. Now we have the area on each floor, which is like the total built up area divided by the number of floors, which will give us an equal area on each floor. And equal area on each floor means that we have the area on the ground floor as well. So if this is the area on the ground floor, this is the this is the plot area or the ground area. So when we calculate this like this will give us ground coverage percentage. And why are we multiplying it by 100? Because ground coverage is in percentage. We have taken out this 450 square meter right now only because it was given in the information, but this will be used in the next part of the question. So don't get confused. I will just mark it away over here, this to this. Okay, this is for the next part of the question. Since I had the information given, I just did the calculations over here. Some of the more informations which we have been given in this question, we had that 10% will be used for roads, for access roads. Then we have runoff coefficient for paved surface 0.9 and runoff coefficient for unpaved surface 0.3. Now the question is, if it rains for 30 minutes with an intensity of 10 centimeter per hour, minimum volume of rainwater that can be collected will be dash. So what else do we have? We have time, which is 30 minutes. It will convert into half hour. Intensity of the rainfall is given. Intensity is given, which is denoted by small I, which is 10 centimeter per hour. This will also be converted into SI units, or the units which which we will be easier to work with. So 10 centimeter becomes 0.1 meter. Now area of paved surface, we have been given its coefficient, so we have to find out the area. So this will be your whole building, like the area covered by building on the ground floor plus your road, the access roads. So this will be, we just took out 125 square meter and plus 50, 10% of the areas which were paved in the way. So we have taken out, and this will come to 175 square meter. Now area of unpaved surface will be basically 500 minus 175, which will be 325 square meter. So you have all this information, but what you're really missing is an equation. So we solve this question by the formula Q is equal to ICA, where C is the runoff coefficient of materials, I is your intensity, A is your area covered by the material, and Q is basically your volume. So because we have to calculate for two different things, we'll do Q1 and Q2. Q1 will be like ICA, which means our intensity was 0.1 into C is your runoff coefficient. So we are doing this. Q1 is for paved surface. Paved surface had 0.9 and the area was 175. So this will come to 15.75 cubic meters. So volume cubic meters. Unpaved surface will be Q2 ICA. 0.1 intensity is the same intensity of the rainfall, it is intensity is the same, 0.3 into 325. This will be 9.75 meter cube, and therefore the required will be Q1 plus Q2, which is 25.5 meter cube per hour. This will be, because this is intensity is 0.1 meter per hour, so this will be per hour, meter cube per hour, and meter cube per hour over here. So this what it means, that per hour 25.5 cubic meters of water is collected. But what will be collected when the time is half an hour? Collected in half hour will be half of this, so 25.5 divided by 2, which will give us 12.75 cubic meters. Question number 52 and 53 is again a linked question. It is linked with acoustics. So question number 52, basic question is auditorium having volume. So volume of auditorium is 4500 cubic meter, and total absorption of all acoustic materials, absorption or A, is 480 meter square Sabine. Sabine is the absorption unit. And we have to find in question number 52 the reverberation time of the auditorium. Reverberation time means the time that the sound takes for it to die. So it does not keep echoing back, it just dies. So that we have to find out. So I'll just give the formula. Reverberation time in seconds is RT is equal to 0.161 into V by A. So V is the volume of the room. A is, don't be confused, this is not your area, this is total absorption. So we have been given this is 4500 meter cube, this is 480 meter square. So reverberation time is 0.161 into V by A, which is 0.161 into 4500 by 480. This will come as 1.5 seconds. So this is your reverberation time. Now question number 53 is to reduce the reverberation time by 0.5 seconds. So reduction by 0.5 seconds, meaning new reverberation time will be 1.5 minus 0.5, which is 1 second. So the question is, to reduce reverberation time by 0.5 second, additional absorption required would be what? So here we have to find additional absorption, which means what will be added to the total absorption that is present over here. So we'll find this. So RT is equal to 0.161 V by A. So A will be 0.161 into V by reverberation time, which means A will be 0.161 into 4500 divided by 1, which will come around 724.5 meter square. Now you have to find additional time, additional absorption. So this is now your total absorption, and you were given 480. So now you have 244.5 meter square. Question number 54 and 55 are again linked, and it's question related to housing. A residential area planned over an area of 100 hectares. Plot area is given 100 hectares. 1 hectare is 10,000 square meters, so this will be 10 lakh square meters. The question is that the plot has been divided into various plots, each having one dwelling unit. So divided into plots. Plot has one dwelling unit with average household of 5 persons. And it's given that, so it's given here plot size, here number. So there are 500 numbers of 500 square meters plots. Then the number of 300 square meter plots is also 500, and the number of 200 square meter plots is 1000. Now we have been given this information that each plot has one dwelling unit with average household of 5 persons. So when we have 500 plots, so we can find out the population here. So so population over here will be, here 5 persons in every one plot, so there are 500 plots, so there will be 2500 people over here, 5 into 500 over here, and 5 into 1000, so here will be 5000 people. You can also find the area of the plot. So there are 500 numbers of 500 square meter area, so that it will be 250,000 square meter. Then here will be 150,000 square meter, and over here will be 2 lakh square meters. So you can see how much information you already have. You can also find the total number of plots basically present. So 1000 plus 500 plus 500 will be, so there are 2000 number of plots present. The total population is 2500 plus 2500 plus 5000, so it will be 10,000. So you have all these questions. So question number 54 was the gross density of the residential sector. Gross density of the residential sector in persons per hectare. So persons per hectare, you already have a hectare that it is 100 hectare of plot. So you have the total population living there. So 10,000 people over 100 hectares plot. So you have 100 persons per hectare living there. So this is your gross density, the total residential density divided by the total plot area. Now question number 55. The question also had that this area is like residential units, but the rest will be devoted for schools, roads, parks and shops, etc. So we have in question number 55 that 20% of population, total population, is school going children. School going children. So it will be 20 by 100 into the total population is 10,000. Be 2,000. Now expected enrollment is 80%. So this is like 20% of population goes to school and expected enrollment in school. Enrollment in school is basically 80% of this, of the number of people who are at the age of going to school. So it will be 1600. So 1600 is the expected number of children going to school. Per capita floor space requirement is given. For every student, floor space requirement is 5 square meters. So therefore total space requirement will be how much? Will be 5 into 1600, which will be 8000 square meter. This means that total space required, you can also understand that this is, you can understand that this is your form of built up area. The total space required is itna, so this is your built up area. Now you have built up area this. So this becomes your built up area, and now you have FAR, which has been provided to you to be 0.5. So you have built up area, you have FAR, and you have to find out the plot area. So using this equation, we figure out that plot area will be your built up area by FAR. Built up area, like total floor space requirement, which is 8000 square meter, and you have FAR 0.5. This will come around 16,000 square meter. Now the answer is in hectares, so you know that 1 hectare is equal to 10,000 square meter. Therefore, like 1 square meter is 1 by 10,000 hectare. Therefore 16,000 is 1 by 10,000 into 16,000, which comes to 1.6 hectares. So that was for your numerical parts. Thank you.